find the area bounded by the two parabolas defined as y is equal to 3x squared plus x plus 2 and 2x squared plus 5x minus 1. So in order to find the area bound by these two curves, we have to find where they intersect, the points at which they intersect. And we do that by equating them. So we have 3x squared plus x plus 2 is equal to 2x squared plus 5x minus 1. Now, of course, we solve for x. So we bring this to the standard form. So 3x squared minus 2x squared is just x squared. And then positive x minus 5x is negative 4x. And then 2 plus 1 is equal to positive 3. And that's equal to 0. Now, if we factor this, we know we're going to have negative 3 and negative 1. So those are the factors. So then our x's must then equal to 3, or x is equal to 1. Okay. So now, what we've identified is that they intersect at x equal to 3 and x equal to 1. Sorry about that. There you go. So 1 and 3. So we are finding the area between x equals to 1 and x is equal to 3. So in order to do that, we have to integrate. So we integrate from 1 to 3. And now we take this top curve. This top curve is actually over here, subtracted by the bottom curve. And now, in order to find which one is the top curve and which one is the bottom curve, if they hadn't drawn these pictures for you and specifically labeled the curves, you'd substitute a number between 3 and 1 and see which one is greater. So we substitute in 2. And 2 into this is going to be, so we have 3 times by 2 squared, which is 3 times by 4, which is 12, plus 2, plus 2. So that's going to be equal to 16. Now, if we substitute in 2 over here, we get 2 times by 2 squared, which is 2 times by 4, which is 8, plus 5 times by 2, which is 10, minus 1. So that's 18 minus 1, and that is equal to 17. So, therefore, we can see that this curve lies above this curve. And that's important because it dictates now what's going to be inside our integral. We need the top curve subtracted by the bottom curve. So, if this is our top curve, then we have 2x squared plus 5x minus 1 subtracted by 3x squared plus x plus 2. And that's dx. Okay. So now simplifying what's inside the brackets, we have 2x squared minus 3x, which is negative x squared. Then we have 5x minus x, which is plus 4x. And then we have minus 1 minus 2, which is negative 3. Now solving this integral, this becomes x cubed. We increase the exponent by 1, and then we divide by the new exponent. So it's negative x cubed over 3. And then this is plus 4x squared, and now we divide by the new exponent 2. So it becomes just then 2x squared, and then that's minus 3x. And we do this from 1 to 3. Okay, so now, substituting in 3, we get negative 3 cubed over 3, plus, now 3 squared is 9, and 9 times by 2 is 18, so that's going to be plus 18. The negative 3 times by 3 is going to be equal to negative 9. Okay, now we subtract when we substitute in 1, so it's minus 1 over 3 plus 2 minus 3. Okay, now this can simplify to simply negative 3 to the power of 2, which is negative 9. Now we have negative 9 minus 9, which becomes minus 18. And minus 18 plus 18 becomes 0. So we get rid of that. Then we distribute this negative in, and we get 1 over 3 plus 2. So that's minus 2 plus 3. So now, finding a common denominator of 3. So 2 is the same as saying 6 over 3, because 6 divided by 3 is 2. So it's minus 6 here. And 3 is the same as 9 over 3. It's the same as saying plus 9 there. And then 1 minus 6 is negative 5. Negative 5 plus 4 is, negative 5 plus 9 is 4. So it's 4 over 3 units squared. Is this area that is bounded between these two parabolas that's represented by the green shaded region. Thank you for watching.